This is a unit cell and you are asked to find the dimension of this unit cell. What is the length? You are been given other parameters like what is the unit cell's type, whether it is a body centered, face centered, and you also been told the molar mass, the molecular mass of this compound. Density is also given. So in that case, how will you find the unit cell dimension? Correct. So actually from the unit cell dimension, you can actually find the volume of the unit cell. Correct. And if you know the density of the metal, you can calculate the mass. See, from dimension, what you can find? Volume. And density is equal to mass by volume. So if density is given, volume is given, you can find the mass. If density and mass is given, you can find the volume. And volume, from volume you can find dimension, reverse engineering. Correct. So density, mass and volume is linked. And just assume volume has nothing but a cube. Right? This is the length cube. So dimension cube. So using these we can actually find the density, or we can find the mass, or we can find the dimension. So let's derive the relationship between these. Right? It is a very accurate method actually. So by X-ray diffraction, it is found that the length of the unit cell crystal is A. Let's suppose we have found that using X-ray diffraction. So we know that this is A. Or let's first find the formula. Right? We told that density is equal to mass by volume. So let's focus on one cell now. One cell. So in one cell we can have the number of atoms. We have seen that in body centered it is 1, in face centered it is 4, in the normal one it is 1, in the face center it is 4, and body center it is 2. Right? This is body center, face center. It is the normal one, normal cubic structure, closed loop pack. Now this number is varying. So let me give a name to it, that is Z. That will nothing but the number of atoms, and that will vary. So for a given cube, let's do a general formula. Density is what? P is equal to mass. What is the mass? Mass is what? The number of atoms you have into the mass of one atom. So what is the number of atom? Number of atom is Z here. Why is Z? Because we are doing a general formula, right? If it is CCB, we'll put Z is equal to 1, BCC, Z is equal to 2, FCC, Z is equal to 4, like that. Z into mass of one atom. So mass of one atom is nothing but my molar mass by Avogadro number, Na. Because 1 mole is equal to 6.022 into 10 to the power 23 atoms. And 1 mole is some gram, right? Depending on what compound we are looking for. For example, hydrogen is 1 gram, like that. So that is nothing but the molar mass. So if you want to find the weight of one atom, that will be nothing but the molar mass by Avogadro number. Correct? This is my total mass of all the atoms in a given cube. Now by volume is what? My volume of unit cell. Correct? So what is the volume of unit cell? Is nothing but A cube. If A is my edge, this is my formula. Density is equal to mass by volume. Mass is nothing but Z. Z is nothing but my number that is based on the type of packing, into mass of one atom, that is nothing but molar mass by Avogadro number, and divided by volume of unit cell, that is A cube. This is the formula I have derived. Correct? And this is a very, very critical formula. Please remember, density is equal to Zm by Na into A cube. This is a very, very critical formula. And with this formula, actually we can find the value of Na also. If we know the density of the substance, if we know the Z by the X-ray diffraction, obviously you'll know the type of packing it is. Molar mass we know, and by X-ray diffraction you find the value of A. You can find the value of Na also, right? So any unknown, you have 1, 2, 3, 4, 5 values, right? There's a relationship between these 5 values. So you know the value of 4th thing, you can easily find the 5th value. Correct. So we'll take some numericals on that now. So the question is, an element is a body-centered cubic structure. So let's first draw a body-centered cubic structure with a edge of 288 picometer. That is, my length of A is 288 picometer. This is my length. The density of element is 7.2 gram per centimeter cube. Density is 7.2 gram per centimeter cube. Right? The question is, how many atoms are present in 208 gram of the element? That is the question. See, density is what? Mass by volume. Mass is something I know, right? This is something I know, and density is also something which I know. So I can actually find the volume of my 208 grams element. Correct. If I can find the volume of this, I can find the number of cells easily, because this volume which I get is nothing but my volume of cells, unit cells. Correct. So here I'm not talking about one atom, I'm talking about, sorry, one unit cell. There are n number of unit cells. So you'll get volume of n number of unit cells. And I know that the volume of one unit cell is A cube. A I know. So with that I can find the number of unit cells. Hope you understand what I'm trying to say. See, there are 280 grams of element. So with that I can find the volume of this 280 grams of element. It will have n number of unit cells. Correct. So let's find that first. So volume of 208 grams of element is equal to mass by density. Mass is what? 208 gram, and this is density is 7.2 gram per centimeter cube. Please note the SI units, the units here. So here everything is gram, so I didn't convert into SI unit. So gram and gram cancel. With that you get 28.88 and centimeter cube will come up. Centimeter cube. This is the volume of 208 grams of element. And it will have n number of cells, unit cells. Correct. So let's find the volume of one unit cell. Volume of one unit cell. So since it is in centimeter cube, let's find in centimeter cube only. And that is nothing but A cube. A is 288 picometer. So let's convert this into centimeter. Correct. So 288 picometer is nothing but 288 into 10 to the power minus 10 centimeter. Correct. So you just solve this. 288 into 10 to the power minus 10 centimeter whole cube. What you get is 2.39 into 10 to the power minus 23 centimeter cube. This is the volume of one unit cell. So if I have to find the number of unit cells, number of unit cells, that is nothing but total volume. Total volume of unit cells. Correct. By volume of one unit cell. So all the volume of unit cell is given here, 28.88 centimeter cube. Divide by volume of one unit cell, that is 2.39 into 10 to the power minus 23 centimeter cube. Please note, is all same units, cancel, and with this you solve, you get answer as 1.208 into 10 to the power 23 unit cells. So 208 grams of element will have these many unit cells. But the question is different. Question is how many atoms are there. Now we'll take the advantage of the fact that it is body-centered cubic structure. Since it is body-centered unit structure, each unit cell will have 2 atoms. So number of atoms will be how much? You multiply this thing by 2. So let me write it here. Number of atoms will be what? 2 into this number, 12.08 into 10 to the power 23. You solve this, you get 24.16 into 10 to the power 23 atoms. And that is my answer. Pretty easy. So from 208 grams of element, we found that what is the total volume. And we know that one unit cell has this much volume. Total number of unit cells we found. We want to find total number of atoms. One unit cell has 2 atoms. Total number of atoms is 2 into this value. That is 24.16 into 10 to the power 23.